Hi, today we'll be discussing the probability distributions. In this video, note that we will focus only on finding the probability distribution of discrete random variables. So, let's get started. A probability distribution is a function that maps the possible values of a random variable to their probabilities. It tells us how likely it is that a certain value of a random variable will occur. For example, to express the probability distribution for the random variable h, which is described as the number of heads when two coins are tossed, we must first identify all possible outcomes and their corresponding mass point. In tossing two coins, we have learned from the previous video that there are four possible outcomes, which are head and head, head and tail, tail and head, and tail and tail. Thus, we have four outcomes in all. We now write all the possible outcomes and the corresponding mass points h in tabular form using the prepared tactile table. Let's fill in the first column with all the possible outcomes. Which are, again, head, 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 tail, tail, head, and tail, tail. And then their corresponding mass points on the second column. For the first outcome, head and head, there are two heads with respect to our random variable, which is described as the number of heads when two coins are tossed. So we will write 2. On the second and third outcomes, only one head turns up. And finally, on the last outcome, tail and tail, no head turns up. So the mass point here is 0. After doing so, we will now set the table for the probability distribution. To construct the probability distribution in tabular form, we need to list the mass points in one column and their respective probabilities in the other column. Hence, we have the mass points rewritten in the first column as 0, 1, and 2. On the next column, or on the second column, we now determine the probability of each mass point. The probability of getting ahead when two coins are tossed. The probability of 0 or no head turns up is 1 out of 4 outcomes. In symbols, that is equivalent to 1/4. Probability of getting one head or one head turns up, we have here 2 out of the 4 outcomes, or we can simplify that into a half. And 2 heads turned up once out of the 4 outcomes. And that is how we construct the probability distribution of the given discrete random variable. For this is the probability distribution table for our random variable h, which is the number of heads when two coins are tossed. Let's take another example given two sets of numbers. First set is composed of numbers 1, 2, and 3. Second set is composed of the numbers 4, 5, and 6. Construct the probability distribution of the random variable S, which is equal to the sum when one number from each set is taken at a time with replacement. Solution entails listing all possible outcomes first of the given random variable S. If we take 1 from the first set of numbers, we can pair it with 4 from the second set. And that is our first outcome. Similarly, 1 can also be paired with 5, giving us our second outcome, which is 1 and 5. Also, 1 can be paired with 6, and that is our third outcome. If we repeat the process to the rest of the given numbers, noting that replacement is allowed, we have the following outcomes. We have 2 paired with 4, 2 paired with 5, 2 is also paired with 6. The last group of outcomes will be 3 paired with 4, 3 paired with 5, and 3 paired with 6. Hence, we have here a total of 9 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9. However, the random variable requires the sum of our combinations. So let's take the sum of each pair of numbers. We have here 1 plus 4 will give us 5. 1 plus 5 will give us 6. 1 plus 6 will give us a sum of 7. 2 and 4 will give us a sum of 6. 2 plus 5 is equal to 7. 2 plus 6 is equal to 8. 3 plus 4 will give us 7. 3 plus 5 will give us 8. And 3 plus 6 is equal to 9. Now that we have already the sum of each combination, then we have already the mass points of S, referring to the sum derived or to the different sums we have, such as 5, 6, 7, 8, and 9. These values are now written in the first column of our probability distribution table. On the next column, we can now indicate their corresponding probabilities. The probability of getting a sum which is equal to 5 is 1 out of 9 outcomes. Hence, our probability can be written as 1/9 or 1 over 9. The probability of getting a sum which is equal to 6 is 2 out of the total 9 outcomes. The probability of getting a sum which is equal to 7 is 1, 2, and 3. 3 out of 9, or simply a third. Next, the probability of getting a sum which is equal to 8. We have 2 out of 9 outcomes. And finally, the probability of getting a sum which is equal to 9 is 1 out of 9. And that completes our probability distribution for the given random variable S. Take note, It is necessary to earn insights and key concepts on probability distribution and how it can be used to solve problems involving discrete random variables. Remember, practice makes perfect. So keep practicing and exploring the fascinating world of probability theory and statistics.